All right, hello. So this is a question that I've been getting from some folks about some of the word problems from the quiz. So I wanted to give you all a little bit of support here. I'm going to go over some of the word problems, and if you had difficulty, these are going to be using not the same numbers, right? So different numbers, but the same kind of question. All right, so let's take a look here. So the first one here, I say, suppose you invest $600 at 2.7% annual interest that is compounded monthly. How much money will your investment be worth after 9 years? Okay, so since we're talking about compound interest, that means we're going to be using the compound interest formula. Compound interest formula is amount equals the principal, the starting amount that the investment is worth, times 1 plus R. R is your interest rate as a decimal, over N. N is the number of times compounded per year, to the N, number of times compounded per year, times T, number of years. So let's go through our problem here and see what values we have. So first of all, P. What's the starting amount? Well, $600. That's our starting amount. Okay, so I'll go ahead and put that in here. Next, let's look for R. Okay, the interest rate. What's our interest rate here? Well, it's right here. Okay, but 2.7 is not the interest rate. R is going to be the decimal version of that. To get the decimal version, you can take that 2.7 and divide by 100. Okay, that'll give you the decimal version of the percent, which is 0.027, like that. Okay, so it'll be 0.027 in the numerator like that, over N, the number of times compounded per year. Well, we're told here it's compounded monthly. So if we're compounding monthly, how many months are in a year? Well, there are 12. So N equals 12. That tells us that. Okay, again, we're going to use N in this part of the formula, same N as this N right here, right? Same letter, same number, so 12. And then finally T is the number of years that this investment's happening. So 9 years right there. So that's our T. So times 9, like that. Now, the next place where students can get into some trouble is actually like evaluating this. That is typing it in their calculator. So I'm going to show you that here, excuse me, real quick. And I might have just flipped back and forth, so forgive me. Okay, so, okay, 600 times 1 plus, okay, so we'll start with that. Okay, so in your calculator, 600, and then you can just put a parenthesis. If you want to put the time symbol, you can, times 1 plus. Now, when we do the R over N part, we type this part into our calculator, okay, we're going to need to use parentheses. So really, you should put a second set of parentheses around that fraction there. So 1 plus parentheses, 0.027 divided by 12, close parentheses. Okay, and now we can close the second set of parentheses there for the 1 plus 0.027 over 12 thing. And then we're going to raise it to a power. Okay, right, now be careful here as well. That power we're going to raise it to, it's 12 times 9. So that, we also need to make sure we put in parentheses in our calculator too. So to the parentheses, 12 times 9. Okay, and then hit enter. And voila, there's our value. $764, and we'll say 83 cents. No need to graph here, right? This is not a graphing problem. Okay, you just type it in and just evaluate it. Okay, so 764.83. And again, I use the squiggly equal sign here because we're rounding, right? It's not precise. All right, that's it. Let's try the next one. Mr. Wade buys an antique for $900, and experts estimate that its value will increase by 8% per year. Write an equation for the value Vx of this antique for X years after purchase. Okay. So in this case, you can use the compound interest formula if you want to. So that would be, A equals P times 1 plus R over N to the NT. Or you can just use the annual growth formula, which is A equals P times 1 plus R to the T, like this. And you'll see why you can use both of those, even though they look really different in a second here, okay? So let's focus on this, the simpler one, okay? Actually, no, let's focus on this one first, because that's what we just worked on, so we'll get some more practice there, okay? So, P, okay, principal here, we're starting with $900, right? That's the initial investment there. We're going to multiply by 1 plus R. What's our interest rate? Well, it's right there, 8%, and that's our R. But again, as a decimal, it'll be 0.08. And then over N, the number of times compounded per year. Now, you'll notice here, it does not say anything about compound interest. Okay, it doesn't say how many times is compounded per year, which means, since there's no number of times indicated, that it's probably just compounded once per year at the end of the year. So we're going to put this over a 1. So say just N is 1. And so the N is 1 up here as well. And then times T, well, how many years? Well, we don't know in this case, right? For X years. So it's just for some random X value. So this is our T right here. So let's just say 1 times X. Okay, so I can simplify that and just say it's 900 times 1 plus 0.08 divided by 1 is just going to be 0.08. And then 1 times X is just X. Okay, so I really want to simplify it even further, and you don't have to do this, but there it is, really simplified out. Okay. Now, compare that to this formula. I think you'll see, again, principal, the starting amount was that $900. Okay, times 1 plus interest rate as a decimal, 0.08. And then to the T, well, in this case, our time is the X number of years. So there it is. And you can see that they're the exact same thing. Okay, just add the 1.08, you get that. Now, next question, though, what will the antique be worth in 12 years? Okay, so 12 is now our X, or our time, right? So we're going to plug 12 in for X. No graphing necessary here. We're just going to put the 12 in for our X, like that. Now we go to our calculator, 900 times 1.08 to the 12. Okay, clear this out. 900 parentheses 0.08 to the 12th. Okay, again, it's a good idea to put parentheses around the 12 in this case. It's not necessary here. Whoops. Okay, it's not necessary, but it's a good idea to be in the habit of. And there's our answer, about $2,266.35. Oops, and I missed the 35. Okay, so there's that one. Last one here. After how many years will the original value of the antique double? Double, okay? So after how many years? That means we're solving for, right, because we don't know the number of years. We're trying to find the number of years. So we'll rewrite our equation here, 900 times 1.08 to the X. Okay, now here we have two unknowns. We don't know the final amount, and we don't know the number of years, but we're trying to find this one, okay, because we're asked to find for how many years. So that means we need to come up with an amount here. Well, we do have an amount. The original value of the antique to double. What would be double our original amount here? Well, it's going to be $1,800. Okay? Now is when you want to graph on your graphing calculator. Graph the left-hand side, graph the right-hand side, find that point of intersection. Okay? If you want to make life a little bit easier for yourself, you could take a step here in simplifying by dividing both sides by 900 first. Since this is 900, times that 1.08. If you divide both sides by 900, you'll get a 2 over here and a 1.08 to the X here. This will be a little bit easier to graph and see, but we'll go ahead. I'll do this one first, okay, and then I'll show you this second one right here. Okay. So like I said, let's do this one first. So I'll graph 1800 and then 900 times 1.08x. Okay. So 1800, 900 times 1.08 to the x. Okay. Oops, I forgot my other parenthesis here. I'll have to insert that. Oh, I thought I pushed that. There we go. Okay. Now we'll graph. Oops, now my viewing window is already, let's give me zoom. All right, so you guys probably have your viewing window set back to the normal viewing window that looks like this. And of course we don't see anything because our y equals there is really big numbers. So we have to adjust our window, and we need to adjust our y max so that we can see 1,800. So y max, I'm going to make it like 2,000. Okay, because I want to go a little bit more than 1,800. Okay, there's the 1,800, and there's my exponential growth. Will it intersect? Yes. Okay, perfect. So second, trace, go to intersect, hit enter, and then arrow over until you get to that point of intersection. Perfect. Enter, enter, enter. And there it is. 9.006. So we're going to round that up to 10 years, because after 9 years, it won't quite be long enough. Okay, again, we got approximately 9.006. Okay, but round that up to the nearest whole year, because after 9 years won't quite be enough, so after 10 years will, though. And I'll show you this one here, too. 2 equals 1.08 to the x. So I'll graph the 2, and then I'll graph the 1.008. And actually, I should use parentheses here. I should use parentheses on the x, too. Just good habits to be in there. Okay. There's the 2. There's the 1.008. Excuse me. Oh, it was not 008, sorry, just 08. That's my bad. There we go. I was like, it didn't cross. Okay, so you can see where it crosses to the right there somewhere. So we'll do second trace, go down to calc, or intersect, I mean, and then arrow over to that point of intersection right over here somewhere. Right there, and hit enter, enter, enter. 9.006, same number we got for the other one, right? Okay, we just simplify the equation a little more. So again, 9.006, x is about 9.006, which will round up to 10 years. Okay, so hopefully that helped. Let me know if you have any further questions, yeah, good luck on the quiz. Bye.